Yep.
I'm not late, right?
Oh, a second.
Are you in charge?
Absolutely.
Excellent. Well, welcome everybody. Come on, keep coming in. Well, this is a panel that we were planning that I had talked with Boris about last year. It was in relation to compiler build time switches for optimizing your code. But Boris said, no, I'm not working on that. But it'd be more spirited debate than talking about build packages. So, I invited some people to come, and I'll let them introduce themselves.
I'm Titus Winters. I founded Absail. I'm the chair of the study group on tooling for the C++ library, or C++ standard, I guess. I don't know why I'm here.
Because you like to talk. I'm Manuel Klimek. I run the C++ tools team at Google in Munich. We do stuff like clang D, clang tidy, clang format, and we also make the build faster. And so I did a lot of implementation of like modules in Bazel. I guess that's why I'm here.
And build all the tools for me.
My name is Boris. I work on Build 2, which is an integrated build tool chain for C++.
I'm Robert Schumacher. I build VC package at Microsoft, and I'm on the acquisitions, install, and release team at Microsoft. Ooh, the new one.
My name is Paddy McDonald. I've worked on a whole bunch of different internal development tools at Microsoft over the last 20 years. I've been thinking about tools acquisition for the last year inside Microsoft, trying to get it to change. I'm going to be handing that out to Robert's team.
So if you haven't, this is a panel that's a session that allows you, the users or developers, to ask questions. So please come up to the mic if you have any questions or any horror stories that you guys want to tell.
Oh, ghost stories, yeah.
Oh, tell us a story. Just go on.
Well, you should have come to my talk, or at least you should watch it on GitHub, because that's entirely what the talk is about. It's just stories, and terrible stories, about the terrible things that people do in their builds.
Nice.
And how that makes packaging really hard.
It was a good talk. I had a choice. It was flip a coin.
And you went to mine, and it was worth it, right? No!
Sorry.
It was a very good talk.
I know.
He has to say this now, because when he told me it before, the mic wasn't on. So.
What was the title on the talk?
Don't package your libraries, write packageable libraries. Seriously, you guys are just here to hang out? Like,
You can summarize. No,
Oh, yeah.
I can start. My name is Alexei. So I was doing development in C++ like for already 20 years.
I'm sorry.
Yeah, thank you. And it was always under Linux. And all these years, what I have seen, there is a huge gap of development environment between Linux and Windows. Well, I really like that idea that on Windows we have Visual Studio all together, and on Linux we actually have all other great tools we can put together. But what's really frustrating that we still can't get a good build system and a good IDE which works well with that build system. And I see it's getting better. It's about like CMake, Ninja, other build tools. It's getting better, but it's not quite there yet. And in some cases, actually losing a little bit of this Linux edge to be able to integrate all other tools together with C++ sources. So maybe you can tell me why this is really happening, because like there is really many developers, and they still use Vim, they still use Emacs, and this is kind of really not the best way I see you can develop more C++ code. Sure. So I think Vim and Emacs can be an IDE, right? And the point is that with LSP, I think Microsoft has actually created the language service protocol.
Microsoft has created the missing piece that allows us to basically hook up editors and also IDEs to really powerful like language-specific backends like Langly, and that's all very recent, but it's happening.
Yeah, if you like them, use VS Code with the Vim mode extension. I hear it's excellent, personally UMass, but anyway. And with the C++ language extension, you get like debugging support, you get IntelliSense, you can go to definition. It's awesome. And it integrates with build systems.
Yeah, I noticed that tools like Visual Studio is getting like the CMake, remote debug.
VS Code.
VS Code is more like an editor, I think, at this point. So I look at this more like from Visual C++, or like running it on Windows and doing remote build and debug. Because there are great editors, like yeah, you can do this Vim completion, you can do many things. But if you want to do more, you really need IDE to understand the code structure. It needs to know how to compile the code. It needs to know how to turn it into AST.
Yes, and that's part of the language server protocol, is it allows the build system to export that information into the IDE or the editor so that it can provide that sort of rich information. And this is what VS Code does. I strongly recommend you take a look at it. It has full debugging support. You have breakpoints, you can look at locals, the whole works on Linux, Mac, Windows, all the way through. So seriously, take a look at it. It's labeled as an editor, but you'd be surprised if you're coming from, say, Notepad.
Yeah, I tried it like a year ago. The Klimek haven't been there yet, I think, at that time. So I definitely try it. Thank you.
Also, my question would be, what specifically are you missing?
In where?
Like when you say it's an editor, not an IDE, and like I get that a lot,
yeah,
and then when you ask people, they're very different answers.
Yeah, I think modern development, you can just using an editor with the code is very suboptimal. You can do amazing things with an IDE, which had a good introspection of the code. And there are many things like completion and other things. Editors actually can do that. But the things like refactoring and generating the code, those actually require much deeper understanding of the whole code base. Because today, if you take like C-Line, well, I don't use Visual Studio, but C-Line does that. That does that magic. And it's been doing that magic for years with Java. For years, right? But to C++ is just coming now. And this is actually very exciting, because you can, you really need, you need the code editor, not the text editor.
Honestly, I think part of the problem there, and I could be completely talking out of my hat, I think part of the problem there is that for C++, there are an awful lot more very, very, very big shops, right? And there's groups like us, right? And when we talk about refactoring, we mean a wholly different thing than whatever your IDE is going to do. And in a language like Java, which had less time to build legacy like that, and tended to smaller, less monolithic repositories, code bases, projects, it is much easier to have something like Eclipse, refactor menu options that like will do everything you need for your project. But every refactoring that's ever been done in an IDE is, I can't count that small compared to the things that we talk about as refactoring on like Abseil and C++ libraries. Which means like we have been investing in a thing that isn't what you need for your IDE, and it's just like a difference in like focus, a difference in resources.
Well, yeah, I think we're talking about the same kind of refactoring, because I read what you did at Google, and it's exactly the kind of refactoring I'm talking to. It's like refactoring across the whole base. Yes, I understand the scale.
I mean, we do have the use case for like more small scale, like I want to define my project, and because I exactly know which parts of the code base I'm working, I want everything to work like at head nicely in that kind of environment. And we haven't invested in that yet. And the question is again, right, specifically I would be interested which refactorings you want, because the big problem is that lots of people, and that goes back to the editors too, right? Because C++ is such an old language, people have started to develop their very own workflows, and basically everybody I talk to has a very different workflow and uses different kind of refactorings and wants different refactorings. So it's very hard to make like 90% of the users happy, because with every huge investment, you make like 5% of the users happy. And that's a really bad return on investment. And that's, I think, part of where the problem comes from, right? We have to make Emacs users happy, Vim users happy, Sublime users happy, VS Code users happy, people who want their renames, people who care about other things, right? And that's, I think, where for us the main problem lies in.
There's one other problem, which is C++ is inherently difficult to refactor. You've got a lot of conditional compilations going on with pound defines on command lines. And having visibility into that at edit time, if you don't fully understand the build system, just makes it a huge problem. So the amount of investment you have to do to even get just outlining done properly, it's very, very difficult.
Yeah, which is another way of saying, all y'all need to stop doing that, like, if-def crap. And then we can get you better tools.
It will never die.
It will always die.
No.
If context.
So no Chrome? like right, we in our internal code base, like for the whole like Linux server stack, we actually have a pretty nice like mostly one configuration thing, and we can do really nice large scale refactorings there, and we have done it. But for the Chrome folks, we have historically been unable to deliver because they need Windows and Mac, because their whole code is full of if-this for Windows and Mac, and if we don't understand these, our refactorings will be wrong.
Thank you for the questions.
Thank you for the answers. Thank you.
Hey. So
Hey.
I've been coding for maybe close to 30 years now. In C++. So what do we do it? What do we need to do so next time there's only one of you up there? Meaning we don't have to understand 20 different build tools to be able to write code and deliver it to our users.
Figure out what you want and tell us. And make it clear, and make it in a way that actually is what everyone wants. As long as there are many different wants, there will be many different us solving those wants differently.
Yeah, fewer users, I think, would help. Because right, I was in a talk this morning about Evoke, which is basically Go build for C++, and it's great if you only have C++, and it's a really nice idea, but it has this very specific use case, right? And there are other things like Bazel, which also has very specific use cases, especially, and you pay for that, right? And so users with different use cases need different build systems, unfortunately.
Well, I think we can look at version control systems as an example. It can actually happen. I know not everyone loves Git, but I think more or less everyone is okay with using it. And
I just disagree with you, but
I mean, maybe, yeah, I guess there's some interest. But I think this shows a potential path that we actually get a good enough build system that maybe, or package manager that maybe a majority of the community can at least switch. I don't believe we're at that stage right now, though.
I think one of the other things that makes it complicated is the long dark period. The very fact that C++ was basically stable and stagnant for 15 years meant that an awful lot of crazy bad ideas were able to spring up and successfully depend on what happened to be true in those implementations at that time. And because nothing was changing, there was no forcing function to like flush out the bad ideas. And the side effect of that is we have a bananas amount of weird legacy that the committee never promised would be like. There is nowhere that the standard library, or that the standard says we promise ABI compatibility, right? We walked into that by not changing anything for 15 years and by allowing everyone to like deploy SOs of everything, right? And now, collectively as a community, we are paying for that wildly, and it has some upsides, but like there is huge performance and stability and usability cost that just comes, like, I always talk about Hiram's Law. Like, with enough time and enough users, every observable of your system will be depended on by someone. And then you go to, old wisdom, like a rolling stone gathers no moss. We stopped rolling for 15 years. We gathered a lot of moss. And now it's going to be really hard to like ever actually reunify. And it's going to take many years of like not giving up and like pushing on things to get a little better. And I know that I'm wildly idealistic. And someone has to be.
I think the other thing we need to talk about is the build system is not just about driving the compilers and the linkers. There's a whole bunch of other steps that happen pre-compilation, post-link. There's a whole bunch of tools that get plugged into a build system. So even if we talk about solving just for the C++ compiler and linker, we then have to think about all of the other tools that come before and all the other tools that come after. So it's not a simple problem of just, hey, we need to figure out how to drive the compiler. It's how do we drive everything that leads up to the preprocessor steps. If we're building a compiler, are we running LAX and YAC? If we're post-processing because we're doing signing, if we're post-processing, we're doing packaging and pushing out like that. So it's not just this one set of tools that we need to worry about. It's a very, very complex pipeline, and none of the tools do it well.
But I think the great thing with adding to Titus's point is there is a lot of young blood coming into the C++ community and getting involved in the standards group and
Demanding better.
And if you want something to be changed, you gotta do it. So.
Yeah, PR's accepted, right?
Solicited.
Yeah. Reviewed, right.
So workflows and IDEs and Emacs and all that was mentioned. And I'm curious, if it's not rude, would you guys mind letting us know what your daily driver is? And if you wish you had a different build system that supported a different one?
My daily driver is a horrible, kludged together legacy system built around MS Build from before it supported C++. We're in the process of revamping that and moving forwards, and I'd really prefer anything that had a debugger. If you give me a build system that has a debugger, I'll use it. I don't care about anything else.
So I use Visual Studio. I use the CMake support as well as the MS Build support, so in 2017 the open folder CMake support. And then I'll also use VS Code occasionally if I need to hack up something that it's just like, oh, I need to open this file, change one back, and close it. And then occasionally I'll need to work on a Linux system where I don't have X11 forwarding set up, and so I will use Nano or Emacs in those environments, and then I'll just build from the command line. But I typically don't do the majority of my development there. Most of it happens in Visual Studio and then copy over.
So I use build 2 naturally. So we actually use build 2 for its own development, which I think is actually a great reality check for what you are doing. My editor is Emacs, so I built it from Emacs and on Linux.
I use Vim with Clangy and Bazel. And I just actually tried VS Code with Clangy on my MacBook. Good.
No. I write a lot of docs. I do a lot of code reviews. And when I do actually have to edit anything, I use Emacs, and it is pretty stripped down and not up to date. So I'm bad and weak, and I should learn from Manuel.
I work in the mobile phone industry using Android, so of course I use Android Studio. And then trying to get even deeper, I use the ARM DS5 compiler for SIMD code.
And was there any that you wish that you had access to or wanted to try out, but your system didn't support it?
I haven't gotten to that point. I know that we used an IDA disassembler because you cannot do disassembly in the Android Studio to actually debug your assembler code. So that was, you had to basically use the old-fashioned print out what your output was and figure out, oh, I see what's going on. But yeah, so it was kind of interesting. I was really racking my head trying to figure out what was going on. And then I was talking with some people and they said, oh yeah, we were using ping signals, you know, if it made this sound, we knew that we hit this exact register. So I said, oh great, I would just print it out. But yeah, it was a nightmare. And once I figured it out, boom, it was problem solved. So.
I will amend my answer. I also use Godbolt a lot.
Everyone else has told us that's
Well, maybe I'll ask a question. Once. Can we all agree to prefix our includes with a library name?
Seriously.
No, you can
You can also line up.
Is anybody not doing that?
Yes.
Yeah.
Yes. I had slides in my talk. They may not have come up though. I had this cut a little bit.
Yeah. So are you up for feature requests?
Absolutely.
Anyone, actually.
Absolutely.
In particular, I've got you and Manuel. Oh, fine.
Yeah.
All right.
We gotta have it, we're recording it.
I did want to mention that for the tools that would be really nice that aren't on my platform, Valgrind is really awesome, and I primarily develop on Windows, and so that not being as easy to access is unfortunate.
You should be able to use, yeah. Exactly.
Well, it's not as easy as, like, apt install Valgrind and then like, oh, Valgrind executable, done, easy, right? I haven't.
Download Clang, use sanitizers.
Yeah.
And Clang is 20x faster.
Or more.
Oh, yeah, I need to look into the LV and stuff.
And it captures, like, it finds more bugs, I think.
Yeah.
Like thread
At this point,
sanitizer.
not only finds more bugs, and I will cop to the fact that I work with Titus and Manuel. So, Manuel, can I get Clang D support in Emacs?
Wait, I want to harp on this sanitizer thing for a second.
No, I will help you.
Like, I have said it before in public forums, and I am not on the sanitizer team. I'm like a cousin of that. Second cousin, maybe?
Second or third cousin.
Like, the difference between using these sanitizers and just having a debugger is larger than the difference between using a debugger and guessing. Right? Like, if you are not using the sanitizers, get with the program. Right? Like, there is literal magic and it is free. Go invest in that. Anyway.
No, I
So can I just add, thread sanitizer is really slow though. The one thing I miss is a much more powerful machine for thread sanitizer.
Thread sanitizer is painful. There's not a whole lot that can be done there at the moment to make it much faster just because of what it has to do. The serialization is kind of painful.
Your wish is granted.
Yeah.
It already works.
It does work. And
What was the wish? Emacs Clang D?
Emacs 90?
Yeah.
Do you have documentation?
Probably.
No, we're Agile. What are you talking about?
Should I plug Ben?
Ben is not an Emacs user. Ilya is sitting here somewhere. Yes, Ilya knows how to set it up.
Sweet. Thank you.
Ilya
So related to that, I
Totally.
tried VS Code recently, and I did really enjoy it. I have an unfortunate work environment though, in that I'm not going to forward X11 to my home from work, and I SSH only into my machine. So is there any hope for, because isn't VS Code built on top of JavaScript and
It's Electron Shell.
So yeah, is there any hope of having Electron shelled in a terminal VS Code?
So I certainly know nothing about that. I don't work on VS Code, but you can X11 forward through SSH, right?
You can.
You can also SSHFS, works awesomely. It's the magic that a lot of people still don't know about.
Yeah,
But then you need to forward Clang D and everything.
No,
Hard to set up.
Well, you could run that locally, right? You just SSHFS and then go for it.
maybe.
No, definitely. You just
Definitely.
Yeah, you just-
I just
No,
really-
because you need to run the build system, and the build
Yeah.
system runs on the machine.
no, you run it locally because it's
No,
all
you can't
Mac.
because it's a MacBook.
Yeah,
only,
can't do this in MacBook. Yeah.
Oh, well, get a
And it's-
computer instead of. Sorry, I don't.
No. It's a fair copy. It could be worse.
No,
It could
you
be Chromebook,
can't.
so.
Our remote, you can't access the remote builds from home, right?
Yeah.
It's-
So it's a little complicated. So I was hoping for an electron shell on in a terminal. But
Yeah, so I didn't, originally VS Code didn't work over X11 forwarding, if I understand correctly, and they managed to start making it work at some point. I think that's the story there.
So, yeah.
Not totally sure myself.
But relatedly, by the way, one of the things to answer his question a little bit more, which is that there are ecosystems built up around the tools, and that's part of what, like, Microsoft has built an incredible ecosystem because they have full control over the pipeline. Apple has done the same thing. Linux, no one has control over that development pipeline, and there's no return for anyone to do it outside of large shops where everyone can build the tools that just they need for their internal use, and then there's no reason to make it work for anything other than their own use.
But there's so many Legos.
There are so many Legos, so many Mindstorms. But anyways, so I had great questions, but I really want the various tools to work better. But yes, you should definitely use the sanitizers more. Thank you.
Titus, you always said that you should never use and write code like if-defs. Yeah, but what other way to know about system environment and target environment you build it for?
So this is sort of a guideline, not a law. Like, there will be times when you clearly have to have some if-defs and targeted environments and things in there. I'm sort of optimistically actually sort of fond of the Go approach, wherein any sort of conditional compilation is not at the line-by-line level, but is actually a property of the build system querying the platform properties and swapping out which file is used for that, which is at least more structured, right?
Okay.
Because, like, I think a lot of the difficulty in tooling, like just saying, like, avoid your if-defs is overly simplifying. A lot of the difficulty in tooling is that there is no rigor in people's use of if-defs, right? Like, there's almost no understanding of, oh, this project that I'm depending on has an if-def for some macro, right? You, more often than not, will just be like, well, I want to change that macro, so I'm just going to define that in my build, right? It may be the case that that project already has logic to try to infer that macro, right? And it's not actually intended to be a build flag. It is a internal shorthand for other build flags, and there's no public or private on who gets to set a macro, right? And then on top of that, we make it worse by making APIs conditionally available as opposed to universally available and, like, maybe degrade or just make whole blocks of code evaporate, right? And that's all kind of unnecessarily complicates the problem, right? Whereas if we had more rigor in saying, like, this is an actual build switch, you are allowed to toggle this. These are my internals that I'm using, like, I'm taking all of the, things that were set by the toolchain and things that I've extracted from the platform and, secondary, and, like, I'm using this as shorthand, like, to configure things.
I get it.
We would be in a much better place, right?
That said, the platforms make it really hard to write abstractions that are really performant. It's really hard, for example, to write a network stack, right, that works well with the Windows and the Linux network stack, or UI that works across, like, Mac, Windows, and Linux. And so in the end, right, if you want to be really fast, you will have to kind of cater to that. And if you don't want to be really fast, you just don't use C++.
Or you can use a library. I mean, there do exist wrappers that will allow you to escape ifs.
Yeah, thank you.
Hey, so I work in games.
I like games.
Yeah, games are fun. More importantly, games have a lot of data. So we have a huge source tree, and then we output some relatively small artifacts. So it's a really great domain for build system engineers, if there's any build system engineers that want to do something fun. So as a percent of a game, C++ is like a really small amount if you measure just bytes, but as a build time consumer, it's kind of obviously really bad because of the compiler. So Build 2 actually was the best talk I've been to at CppCon because it presented this like reality and showed like, okay, here's an incremental step towards a better future. I guess I'll start with just a simple question, like what developments in the compiler are you really excited about in terms of improving build times? And well, yeah, we'll just go there because someone's like
modules.
Really modules fix everything.
Cool. That's
Which is the amusing joke because everyone says that, and this is actually a case where that's true.
Yeah.
Number 2, you want a funny story?
Always. That's why I'm here.
Yeah. So, do you use streams anywhere?
Wait, like
less than?
No, God no. I mean, we're in games. Like,
sure. I mean, good.
We use pointers. Like, we're really excited about that.
Pointers, you're fine. So the story that I get from my other half, that would be Chandler, is that for like an average project, average code base somewhere, right? With sort of average use of OStream, cout, logging, whatever, you may be spending somewhere to like 10 to 30% of your time resolving operator less than.
Yeah, we do for sure. I mean, if it's not operator less than, it's some other like symbol.
Equality. Equality is a big one.
Oh yeah.
Right? Like, but it is horrifying how poorly designed that API is and how much we are paying for it. So, like, just add parentheses and redesign the API, and you could do so much less lookup. It'd be amazing.
So the other question I have for you is, when you talk about build throughput and the time you're spending, the problem that we always face is debug build versus release build. You know, do you want the final performance coming out of for games, you don't really want to be spending the time in a debug build. You want to get to where you want to debug as quickly as possible, so you want to spend the time up front for actually doing the optimization. Then there's all the debug information, you know, there's a lot of things that we've been trying with things like FastLink, but all that does is push the time you're going to spend actually into that debugger session. So it's kind of a balance between what's the compiler like actually doing for you as far as the resultant code and how fast you want to run through it. So I think the conversation needs to change around, it's not just about the build time, it's how long does it take you to get to actually doing the thing you're interested in, which is getting to the debugging point, getting to the point where you can actually observe the changes that you've just made.
Well, I will say developer time is expensive, and so if I can go to my studio director and say I can save developer time, I don't have a blank check, but I have a check. I can always get more machines. And what makes C++ so bad is that it caches nothing. So I've probably recompiled the standard template library like a dozen times in an hour. And that is the kind of thing that I think there's like low-hanging fruit. But it's super hard because the fruit is surrounded by like 30 years of C++, you know. So yeah, that's all I wanted to say.
If you actually can get a lot of machines, C++ actually does nicely like parallelize in its current form. Modules actually destroys that to some degree because now you suddenly have a dependency chain of things that you need to compile in order, and then you need to make your compiler much better at detecting what your actual interface with your implementation dependencies are, because otherwise you're like waiting for modules to build that you don't need to wait for. And to a different point, right? The cynic in me also always goes like, well, the problem is you make the build faster. Like, we have made the build multiple times faster over the past years for our internal build. But people will always find a way to take that time and do something with it, right? Like not too long ago, I had somebody saying, well, the build is still slow. I have this thing that takes, like this CC file that takes 1.5 minutes to compile. And I looked at it and I saw that it used some template library, and I'm like, yeah, this recursive template's probably n squared, and somebody jumped in, no, it's exponential. And I'm like, sure. And it was doing something really, really cool, but so it's the old problem of we humans kind of have this time. We're at a maximum willing to wait for something, and then we'll just do stuff until it fills that time.
Oh, yeah. I mean, anytime we make the build faster, that just means someone puts more stuff in, right?
Yeah.
Until it's like intolerably slow. Like the build is going to be so slow that it grinds the team to a halt. Like that's how it's going to work, because otherwise the team is just going to
Go forward.
Are you on Windows or some other platform?
I mean, we'll use anything. We're not on a platform. We're mercenaries. Like we're just going to like make computers warm.
I know ways to speed up your Linux builds, but
C crash, Windows ECC.
no. Anyways, go ahead.
I want to know too.
So I have a comment about sanitizers. They're great, and everyone should use them. But for some sanitizers, you need to rebuild the world. Rebuilding the world is really complicated, especially on platforms where they have great packaging systems, and you just do apt-get or some other yum thing, and then you get a library that is already built for you in release mode without any sanitizers, with no way to get them. I found out with my experience contributing to a lot of open source projects that people will just want to use those. They will never use any other packaging system like CppCon or any others that exists where you can add your flags to rebuild the world with everything. So the adoption of sanitizers has been just blocked by those things. It makes it so complicated. I know some sanitizers can be easily be used, like address sanitizer. You don't necessarily need to rebuild everything, unless you have a hybrid build and some parts are built with address sanitizers, some are not. Then you get ODR violations and you run into things where, oh no, you didn't actually set the right bits, and then you get false positives or you don't find bugs. But those are rare, but for the most part, it is really hard. I want to use memory sanitizer on so many more projects. What can we do as a community to improve the situation there? Because if we don't do anything, no one, or very just experts will use sanitizers, I believe, and it is really sad.
Do we have Debian package maintainers here? No. Would be great if we could get Debian packages for these.
Like, build source, yo. Like,
I know, yeah.
Yeah, like everything has to be rebuildable.
I mean, that's what I do, but
I
don't want
know.
people to do that when they just use free services where they have a slice of 10 minutes just to build everything. Makes it really hard.
Like, on the one hand, I understand that. On the other hand, I strongly suspect, I mean, I guess we could survey. How many people in the room would be uncomfortable if they see a function that has an assert in a .h? How many people that have their hands up are willing to come here and explain it? One brave man.
So just to repeat the question, you want to know why we're uncomfortable when we see asserted H in a C++ file?
No. In a header file, you see a function that includes an assert statement. ODR.
Okay, so you have a function which has assert, like on all the school style assert.
In a header.
Well, usually I would prefer to have an exception rather than assert, because I think it's...
That's not the question.
Yeah, yeah.
Not about design.
Okay, maybe you need to find somebody else.
I can say one thing, what you
Yeah, right. Because everyone keeps pretending that they understand how the build works, because it doesn't usually explode on you. You are living in a house of cards, right? If you build one translation unit with a different set of flags than a different translation unit, and you link those into the same binary, you are on very thin ice. And the easiest way to screw this up is to have an assert in any function in a header, because you're like, oh geez, the thing I was working on crashed. So I'm just going to build just my CC file with debug on. And the fact that you have debug on means that assert has a different behavior. And the definition of that function is different in two different translation units. Your program is now full of UB, right? It might work. And if it doesn't, I guarantee there are like 1% of C++ programmers have any chance of tracking down why it is mysteriously more on fire now that you turned on debug mode, right? If you are ever linking together a program where it is not the case that every single TU is built with the same flags, you are a monster, right?
So you're a monster? We do that all the time internally.
And your team keeps it from falling apart. So, good job.
So just hire, like 12 world-class programmers, right? Easy peasy.
Yeah, it's easy. But I have a repository for my project, so that's easy for me. It's not easy when I try to help in the projects and try to convince them that they should just rebuild everything and not just put the binaries. Build for debug and release sometimes, and just link together things. And sometimes it works, and most of the time it doesn't work because you have debug iterators on Windows that gets incompatible and people don't understand what happens.
Rolling stone gathers no moss.
Yes.
I do think that we have to be careful to differentiate between like large shops where people get lots of money for doing this, and they're right. I'm very much in favor of everybody should like invest in building from source, or they're not doing it right. But there's also a huge like community of people out there who do that for fun, for free, and these have very different kind of time constraints, right? And there I think we need to put different expectations in. And as much as I would like to be able to change that world, it's a world that historically has been built up on prepackaged libraries via distributions, and on people like having fun, trying out, running stuff on the weirdest architectures, and being very happy that Debian, for example, has like, I don't know, 5,000 different architectures it supports. And so we kind of have to also, I think, like, do our best to live in that world.
VC Package is a package manager, as you mentioned. We build from source. Send us PRs to make this better.
I don't care. I need to convince people to use it. That's a different problem. And people want to use whatever is provided by the distribution.
Right. So my solution is scare them.
So
Yeah.
do people remember what it was when we didn't have binary packages though? Did you live in that world? Because I lived in that world, and you couldn't use any libraries because there was the barrier of entry to start using a library was downloading the damn thing, finding what dependencies it had, then fighting the stupid autoconf until you finally got it to compile, then spending hours compiling the library, and then maybe start using it.
You can do dependency management without shipping binaries, right? It will be tricky.
I know I can,
but
because there are at least 8 of them, right?
Right.
It's like, that is precisely the problem, right?
Gentoo has been doing that for a while already.
But then you probably don't want to recompile all your whole system with sanitizer flags.
Why not? You want to catch the bugs, right?
To some degree, I guess. You still want to be able to boot your system, I think.
You also don't want to catch everybody's bugs.
Oh man, you could run Gentoo with thread sanitizer on everything.
I think there's kernel
You can try, I think. But
There is kernel ASAN.
There is kernel ASAN.
Kernel ASAN, kernel MSAN, syscallers. Yeah,
But pro tip, don't look too closely at the results for that.
Oh yeah, I wanted to actually have it. So the autoconf, right, you spend the hour building and then finally you're about to try for your project, but you're a cautious developer. You want to make sure that the build was correct. So you run the tests and then half the tests fail. And then you go online and they say, yeah, we have some known failures. And there's 5,000 tests.
And there's multiple steps of this, right? So I'm not saying that you're wrong, that compiling from source is better. Yes, it certainly is better from the point of view of at least you're not invoking UV all over the place. But having binary packages enable developers to actually use a lot more libraries than they could use before, and therefore be more productive and create wonderful toys like phones and stuff for us.
I think that's a false dichotomy, because I think it is entirely possible for us to get to an ecosystem where there are source distributions of things that are easy to fetch and import into your project and build. And the entire necessary cost and complexity of that is nothing more than the cost of the build. And that can be a meaningful cost, but that is time and some CPU.
I would look forward to the glorious future where the new socialist man and woman can use these systems. Until then...
Right, and I don't have to be pragmatic about this. My job is to try to set us on a direction to a better path, right? And if no one is yelling about the fact that this house is on fire, right? None of this actually works. This is a house of cards, right? It's not going to get any better. And there is no provable reason why we can't get to something that is dramatically better. We have to impose some structure and impose some sanity on the way that we package things up. Go see Robert's talk. That was a very good talk, right? These are the things that we should be doing, right? We need to get people that are producing libraries out of the model of, well, this is the way I'm going to do it. Who are you to tell me better? It has to be a community and it has to be an ecosystem, and you will have to play nice. But over a period of 5 or 10 years, we can make progress. It is not going to be quick, but we do have to agree on a direction. I like mine.
to that, I would like to add that it's not just time and CPU. If you want to be pragmatic, you should also add storage for a good caching layer. If you want to make it work for a lot of people who just don't have a big infrastructure. Because storage is cheaper than CPU.
I also would add that I think we are in a very privileged situation to have that much CPU at our hand. And not everybody has that, right? Yeah. And I remember when I compiled Gentoo and then went away for 6 hours while it compiled. And right, this is also a barrier to entry, right?
Yes.
And how many cloud providers are in the process of producing distributed build farms?
Are there any?
I think I'm required to say hey, Azure DevOps free hosting and so forth, blah blah blah, plug.
Yeah.
Right. So
I'm pretty sure there was a big announcement about Google Cloud Build. I think some of us report up through that org. I don't know exactly what the actual dollar cost of building Gentoo on a cloud build farm would be, but I suspect it's less than beer.
I mean, if you want more esoteric suggestions, we could stop having everything built as a DSO on the system and start building more static binaries, so that when you actually build your dependencies as part of your binary, you don't have to worry about someone else's sources having to rebuild a shared object that you then have to share on your system, and it becomes more complicated and things like that as well. You're only just trying to build for your one application. If you would like the more radical possible answer. I don't know. Question.
But don't static library, isn't that the whole point of modules, is just pay for what you need rather than having static libraries?
Sure, but at that which point, what you're doing is the linker will take what you need out of the individual .o files and put it into your final binary.
Security batches.
You'll have the most up-to-date software.
So managing define for dependencies can be tricky. Some libraries, they go full on command line, you have to capture them and propagate them if you want to use their header correctly. And then others just throw everything into a conf file so that you can use their headers and maintain that. I'm wondering, do you guys have a preference for one or the other, and what are the big pitfalls?
If you don't. If you're owning the library, don't make the user-defined macros. Find a way to not require that. Most commonly, this is so on Windows. People are familiar with the whole DLL import export, but not if you're doing static mess, right? If you are only exporting functions, you don't need to mark them DLL import, and the linker will work. So you don't necessarily need the user to define a macro. Yes, you can gain some performance advantages by marking DLL import, but measure thrice and then cut once with that. So you can very easily not require macros in virtually all situations. If you absolutely decide that you really do need to export macros, then maybe have your build system generate a header file. That's not the worst thing in the world. You generate a header file with the right macros that gets pulled in on the user's behalf, and the user doesn't ever see that. So as a user, I just pound include you, I get to write my code. It's just the same thing as everything else. So don't is the answer.
Yeah, I'd also say that as a library provider should provide some ways to be able to be used with common build systems. Right? And if you provide a fine CMake for your library, it doesn't matter whether you do that via some binary that you install or other ways.
And then there's the issue of the library providers need to have some responsibility in what, build flags they require and all of that, which is going to get back to, this is going to get better if and when we start, these are the solid best practices for, what are the inputs to your build, what are the things that, where are there incompatible defines, all of that. Library providers need to take some responsibility for having better build flags and behavior.
I will actually throw in that with respect to this, in VC package, we often patch the headers after we do the build to deal with that. So we add the headers that the user has to define, we add those to the headers that the user is going to use. So from the user's perspective, it is what I said. That's why I believe that this is totally possible for the library to do themselves. They just choose not to for some reason.
Right, so you add it to every header, all the defines needed, just so that it doesn't matter what you use?
Yeah, absolutely. So, they say, if defined, I want to use this thing in static mode versus dynamic mode. Well, we know how you were built, so we're just gonna fill in those macros now so the user doesn't have to do anything. And it just works. So as a user, you just pound include and it just works.
Just to add that it will obviously all fall apart once we have modules, so you won't be able to. Might as well move now, right?
Well, in 2017, that's what everyone said, so no.
Hey, they ship an MSVC/experimental modules.
Yep. Thank you.
What was that first word?
Hello, I would like to come back to a topic which probably you don't like, is C macros. And my question is basically, why is this an unsolvable or so difficult problem? So also I'm not sure if I compare that, for example, to reflections in C++ and dynamic code generation there, probably it's more like sandbox and it's better to reason about. But macros are basically just term replacement systems, which we actually know about how to reason. And I wonder maybe if there's possibilities to think out of the box, how to actually solve this macro mess in some way. So one thing I, for example, know is that on Fedora, the Linux distribution nowadays, like for example the build flags and everything is actually being recorded inside the object files and is then being unified with a linker in the libraries or in the executables. And I wonder, like, if we have like very powerful like dwarf representations, which basically looks like lots of JSON, if we can just like make macros much more like intelligent to reason about and then work on this problem.
So macros do a lot of things. Traditionally what we've seen is the preprocessor runs, and by the time you get to the compiler, you've lost any information.
But isn't that a problem already? Because like you have this like CPP and then later on the compiler, which is, I think Clang actually has like a built-in preprocessor in the compiler, so you basically have like much closer.
Yeah, I mean, I don't know the full details of how Clang is doing it, and hopefully they are starting to propagate that information through. But the problem that we've had in the past has been that you simply have no visibility into what was there before. So by the time you get to compilation, we've run the preprocessor, all the macros have gone, all the substitutions have happened. If we start to record that information and pass that through the rest of the build, we have a hope, but that's going to change how we actually deal with the translation units.
To say nothing of being an exponential sort of problem.
Yeah, and you know, if you look at the way that macros are used, it's not just, hey, I'm going to do one substitution. You have macros within macros within macros within macros within macros with a conditional if-def here, there, and everywhere. They've been horribly abused over the years. They're incredibly powerful, which is why people have been using them. But unpicking that mess is, you're going to have to, there's just so much work to do.
But it's also a little bit like static inline functions which get inline into functions.
It doesn't work out like that. So in your head, when you think macro, you're probably thinking of pound define e underscore inval 1001 or something like that. That's what you're thinking in your head about macros, right? Whereas when we think of macros, the horrors that we are having in the back of our heads are pound define and open curly, or pound defined and, which takes some parameters, and then it takes the first parameter and then it string joins it onto the second parameter, and then puts some open parens and curlies after, which may or may not be closed. You may be expected to call another macro to actually close it, which means that when we see A, the letter A, with a space on both sides, anything can happen in the world of macros. You could instantiate your entire program. And the only way for us to have any idea of what happens in that context would be to require us to look through every single byte of source code that goes into that translation unit. I don't know how recently you've run the preprocessor and then looked at the output size.
I know.
Yeah, we would have to read that many megs or worse of source code in order to have any hope to begin to understand what you do. And at the same time, we just got through talking, someone had a question just a moment ago about, hey, how do I make my builds faster? Well, one way you can make your builds faster is to not pull in so much stuff. Modules will really help with that by allowing us to have only one, ASCII file that we have to mess with, and then we can pull in these much more compressed binary representations. So that is why macros are so horrifying to us as tool owners.
So to me, actually, the macros that are purely like doing these, like you define something that you use. If it's always defined the same way, I don't care too much about that. So Clang actually nicely records all the instantiations, and like when you write tools, it's a pain to deal with, but you kind of learn that. And the problem from the build system is always the macros that change how you define stuff, right? And that gets into the ODR land, and that gets into the, if you have multiple libraries that you can define with multiple different like combinations of what's used, then suddenly you have an exponential explosion of the configuration of your build. And for modules, that means now you have to build n modules, because for each configuration of different definitions, you have to recompile the modules for that, right? And that's really where I think the macros. So there are two different ways for macros. One of them is like just doing basically token pasting and defining stuff, and that's complex and hard to read and hard to tool. But that's from a build point of view, to me, not the problem. And the other one is to basically just have different implementations depending on something, whether something is defined or not.
I was actually not like recommending like actually compiling everything like multiple times depending on that. I was like more referring in at least like giving like introspection into what happens like allowing, for example, to record like state of macros. So GDB nowadays allows like macro expansions, for example, and records like even macros in dwarf information. So you have a lot of like insight into that, and I just wonder like if I wouldn't recommend like to compile everything multiple times or use.
Clang does record the macros in the modules, so we can figure out when they're actually not compatible. And we basically have macros that we know don't matter and macros that we know matter, and it's complex. But
isn't there possibility to just like unify like on a complete build, or just like let's say it's one build and not libraries included, like the macros to one point to see like if there's like kind of like a macro sanitizer?
What are you? I don't actually understand what the question is here.
For example, like this question about like assert came up. Like I think this is like kind of solvable. Like one could use like output from the compilers to, for example, figure out like if ODR like has problems in the work.
Someone mentioned IDL, so iterator debug level in MSVC. So we have a capability in MSVC which is pragma mismatch. So you can embed a string in the binary which will say that this binary isn't compatible if anyone else has this same key set to a different value. So we can say that, hey, this thing was built in debug mode, and then this other guy was not built in debug mode. You probably shouldn't be linking those together because the macros are going to be different, all the data structures have different layouts, and everything's going to explode. So those capabilities exist. That's possibly similar in, there may be some similar mechanism in Clang. The thing is you have to choose to use that. And if you choose to use that, it will work. I didn't I'm so sorry. You need to choose to use that. And if you do, it will work. It'll do exactly what you want. So we have that. Alternatively, if you want us to do this for all macros, then very often that's not going to give you the results that you want. So the mechanisms exist. Use them.
I mean, this goes back to the libraries are written in a way that need somebody to specify these macros and understand what they mean. And like, I don't think you can take that semantic step away, right? You need people to decide what they want their build to actually do, like whether they want to use like a SQL database that you can depend on optionally, or just write YAML, right? And these are the things that people do in their builds.
Yeah, I was just suggesting something like where we could like fail on the safe side. Like we could like error out if, for example, we see some broken configuration, or like depending on debug information, we can't, or it's not like good to merge those things because like different macro configurations have been observed.
And even like being able to detect ODR violations would be really nice. So far we haven't found a way to do that. That's not super much work, unfortunately.
And to be clear, that's not super much work, as in it would be a hard problem to solve. That is super much work. Your build will be 1,000 times slower.
Are there like any other like work on macros? So I've seen a paper like a few years ago from a Brazilian university, like for example, to actually add like more like knowledge about like types into macros in C actually.
No, the vast majority of the committee like effort here is to remove all of the motivating use cases for macros. So modules will get us a long way because pound include will become as mistrusted as pound define. I'm very hopeful that we will merge std source location into C++20, which will take away the need for macros to get you access to file name and line numbers. So all of your logging systems can stop being macros.
Crazy meta classes.
Herb's crazy meta classes is a good one. Yeah, like we're sort of trying to. I have actually, I think, put out specifically a paper that calls for let's make sure we have a complete enumeration of all of the current use cases for macros and a plan. So in 10 years?
Send some papers. Write some papers.
Okay. Cool, thank you.
Anybody else would like to come up?
So Boost has this library called Boost BP, Boost Preprocessing. That could be a start for the list.
This is a little bit of a slightly different flavor question. One of the things I noticed a lot that like jumped out right away with the contracts addition to C++20 is that it has specifically talks about build flags and like arguments to the compiler with respect to like, oh, you can set the handler for contract violations on the command line. And as far as I remember, without any really deep search, this is the first time we've really explicitly talked about build flags in the standard. So now that we have the tooling working group actually like becoming a thing, is it any idea to actually start to standardize on sets of like what build options should look like and what the standard should respect and expect with respect to like build options from compilers?
There have been a couple.
That's a really good question.
Yes, there have been a couple proposals very recently that sort of, as a backdoor, get towards defining like standard build configuration modes. There's a discussion on the SG15 mailing list about std compile that is, if you squint, actually talking about a very related thing. Above and beyond that, I think that I have explicitly called for people to try to work on that problem, and I have not seen anything yet, but it's still fairly early days.
Go. Can I ask you, what do you think the benefit will be of
that? I'm not sure, that's why I asked.
It's a really hard problem because a lot of these are very subtle, and like just defining them will take a lot of time, I think.
Cool, thank you.
Do we have many backend people on that tools committee? Because, yeah, I spend my life more on the back end of the compiler and post-link than I do the front-end stuff, and I get a little bit, if we're talking about setting tool stuff and ABI stuff without involving back-end people.
I know very few back-end people on the committee at all.
We should probably cultivate that a bit.
Hi. So when it comes to build, everybody's always looking about like coming up with one unified build system, and like personally, I don't think it's going to happen just because of all the legacy that's out there. But at the same time, we've had some successes in the past few years when people at least managed to come up with unified standardized protocols that everybody agreed on that reduce some of the combinatorial explosions, like things like LSP, which means that you don't need to have combination of every possible hitter and every possible language. The same for compilation database, which is not used to drive a lot of tools. Do you think, especially as part of like SG15, we can come up with more of these protocols to make it easier to, for example, like figure out what is going on, not only as part of the build, but what is the input into the build, what is the output of the build, because that would at least make it easier to consume products of the build, or figure out what you need to feed into the build to get something reasonable out.
You want to talk about compilation database? I mean, the interesting part about this is that I think we are not sure what the right level is yet, because if you look at different build systems, right, if you look at, for example, Ninja, which is at a very different level from, for example, CMake, which is yet at another level from Bazel, which kind of has, which is more at the similar level like CMake, but Bazel has internally then basically it resolves into it's like node graph on the level where you specify it into kind of like an action graph of things it knows how to execute, which is at a similar level like Ninja if you squint, but not quite, because Ninja is a bit higher level, so it's really hard to figure out something that everybody agrees to, and completely denormalizing creates huge amounts of data that you don't really want to deal with, because then it's slow to figure out anything, or you need a database, and going higher level needs you to like somehow standardize on some form of representation that makes it much easier for one of the build systems than for the others. We have a similar problem with modules where we want kind of tools to be able to interact, but any form we come up with will favor one compiler over the other. So I think we're going to see more playing around with that, and more like kind of tools that just use something and then de facto standards, and then in the end something perhaps will be standardized.
So this is half of my life. The real problem here is even if we solve it just for the C++ compiler tools, I've talked about there's things upstream and there's things downstream. So whatever format that we start talking about really needs to encompass not just the compiler flags, not just the linker flags. Some of these sources are generated from other sources, which are generated from other sources, which are generated from other sources. So you can have this chain of tools, and what you really want to talk about if you're talking about, I'm presuming we're talking about minimizing rebuilds here and understanding what's happening in the build so you can minimize the amount of things you're actually going to rebuild. All of that has to have a common format. All of that has to be expressible, along with hashes as to where you got it from. There's some really interesting conversations around what information we embed within that database or that debug database or things like that. And also, we want to take it, from my perspective, beyond the end of the build. Life does not end when the linker finishes. There's a whole tool chain out beyond that, and persisting that in a form compact enough that it's going to be able to be storable, discoverable. I get a lot of people complaining sometimes that, hey, you've made the debug database bigger. It's like, yeah, I put more useful information in there for tools which you probably don't care about, but are going to solve a lot of problems down the road. So whatever conversation we have around this, we need to talk about the full tool chain, the full workflow, not just the C++ compiler linker.
Not 100% sure that I agree. I think there's room for stages and steps there, and it might not need to be all one thing, but
we should talk about
like
some horror stories.
I'm willing to be convinced, but I would also love if we could try to constrain the boundaries of the problem. I'm not sure if that's possible. Practically speaking, I believe that we have to at least start trafficking in some amount of a compilation database and information about how your compiler got invoked and specifically because of the whole reason I got roped into doing this SG15 tooling thing was because I know a thing or two about refactoring tools. And we're way off in the weeds as far as I'm concerned. But in order to get to the point that I want the committee to have the ability to get an index of how C++ is used in popular open source projects, right? And in order to get to that, we will have to have build understanding and indexing tools and probably package management just to understand what are the popular open source projects, and that would still be a wild success. So.
Yeah. The thing that you can do to help is you can figure out the most popular way of doing things that is close to what you think the world should be, and go help. Go contribute to them. Tell them how the world could be. Convince them how the world could be, and then help them move in that direction. Once things get down to only a handful of really big ways of doing things, then we can look at merging it further, having only 2 big ways of doing things. And then we can figure out what's common between them, and we can come up with the one true way to do things. And trying to force that function through, say, the standard by saying, well, we just desperately want any way of doing things, so we're just going to cram something through there, that's not necessarily going to end up with the best results. So I think it's probably better for us to come to a conclusion as an industry, come to some sort of de facto standard that we all agree this is what works, and then we can proclaim to the world, this is what truly works, as opposed to trying to say, we think this will work, so you guys all do it, and then complain loudly about how it doesn't work, and we can't change it because it's a standard or something like that. Though, obviously, that's not the objective.
I thought that was how the standard operates.
I have been quoted as saying the standard is where things go to stop changing.
Yep.
So are we involving people like Debbie and Ubuntu people in this conversation? Because one thing I've noticed is that, I actually sort of, a long time ago was a Debian developer, and it's just a different world. And, recently, I work on Protobufs, and when we were talking with them recently about the way they look at the world, having a conversation with them, it's like we live in completely different worlds. They think in completely different ways. They care a lot about things like I want to be able to deploy a security fix to a .so and know that it propagated across the whole system. So shared library, like compatibility is really important to them. They don't want to have to rebuild the world all the time. And so trying to sort of achieve any kind of agreement with them seems very difficult. And I just wonder if like they should be involved in this conversation to sort of maybe arrive at some kind of like compromise or understanding. Like, you know, maybe we say something like the libraries that are installed in the system are for the system. They're not for like development. They like you shouldn't develop by downloading a dev package from Debian and building and linking against that. But it seems like they should be involved in this conversation so that we're not sort of fighting each other all the time. I don't know. That's, I mean, I got on a soapbox more than ask a question.
I would say to some degree, what you say in the end is problematic because the system is not decomposed in a way that makes that possible, right? If you want to code against the X you have installed, you kind of need a compatible dev version, otherwise it might be incompatible. But yes, I'm all for trying to talk with the Debian folks, but I found that to be hard.
In my experience, the biggest issue of distribution packages with language package managers that they are kind of solid. The build system and the package manager are inseparable thing. So I think we need to make sure that we have them separate. So it should be possible to build our projects with just the build system, so that it can use packages from the distribution package manager, not from our source package manager. So in my experience, that was the biggest issue. They have, like, for example, with Rust or Go and so on.
Are you volunteering for next year to be on the panel?
I don't know. I think I'm more interested in whether there are people. I mean, I don't know of the people that are at this conference. How many of them are like deeply involved in the Debian or Ubuntu communities? But I just know there were a lot of C++ people here. There's a lot of representation from sort of a lot of the big companies that are doing C++, and I just hope we can get some representation from Debian or Ubuntu people to have some sort of just try to understand each other's points of view, and if there's like ways we can find compromises to make it all work better.
I mean, you had me at hello, but
yeah, right. Tell them to come to the standards meeting.
Yeah,
we'd love to chat. I'd love, right? More people with the standards meeting. I think that's what they were talking about.
I mean, and specifically, like the San Diego meeting and Tacona meeting are both U.S. West Coast, and there's certainly a tech-heavy focus over here. I would not be surprised if some of your Debian contacts are West Coast. I think it is November 8th in the evening in San Diego. The Thursday of that week, whatever it is the SG15 meeting. You don't have to be a standards committee member. Like we would love to have more people to talk. And if a bunch of interesting, unrepresented groups show up, I will stay and talk to them. And I suspect some other people will too. Anything you can do to help.
Cool.
So one of the things that Manuel brought up earlier were a bunch of different build systems, but he also added at least one meta build system in there, which I think is interesting in CMake. So what do you guys think about, and there are other meta build systems as well that will work for each of the different platforms, native environments, or what we've got. So what do you guys think about perhaps even standardizing around input formats, around meta build systems to add things that way and keep going?
What do you mean by standardizing?
I don't know, actually, and that's an interesting one. You've got the language service stuff that you've got ish standardized. So, some sort of agreement of what you guys like as inputs even might work, but I don't know.
I think agreement would be great, and I think practically speaking, getting the standards committee to say anything in this space is not going to happen.
And not just not going to happen.
C++ standards.
Right, and not just not going to happen, actively detrimental, right?
Yeah, no, I agree with you. I was actually hoping for more industry standard rather than language standard.
Yep.
So
absolutely. So you can help by picking the biggest one that is closest to what you want, joining them, and helping them guide in the right direction.
Well, conveniently, we were talking about that tonight. So.
So anybody else have any more questions?
We still have 10 minutes. It was mentioned like API compatibility, and I was just like opening up this topic because I find it interesting. As a system language, I actually expect some kind of API compatibility to compose systems in a binary way. I know it's quite difficult. I know about like some projects that actually like serialize like the whole shell object into XML and diff it to actually make sure to guarantee API compatibility. I just like would like to hear comments. I don't know.
It's more than that, right? Because it is binary compatibility. It's not just what fields do you have there. It is also the interpretation.
Alignment is everything. Like
it is the interpretation of every bit in that representation. So, for instance, today app sales shipped are long-awaited hash tables, and this is one of the examples of, oh dear Lord, we are not promising you binary compatibility. Specifically because in order to, like, you're aware of security, I hope, because you all should be, hash flooding is a real thing, right? In order to protect against hash flooding, right, you probably need non-deterministic hash iteration ordering. That is an awfully hard thing to do if I have to interpret the same bit pattern in memory in exactly the same way, right? Like, API compatibility is, in this sense, harmful for security. API compatibility is harmful for optimization, right? The stood hash implementations that are currently powering all of your hash maps are 10 years old or more. I strongly suspect none of them are vectorizing. Right? The hash functions that we shipped today will kick the pants out of those. And you will never have access to those because you have API compatibility. Right? Like, you're paying a ton in all sorts of forms for that. Right? Whereas, like, my motto is just build it from source, yo. Right? Like, if you don't have to have binary compatibility over time, like, pick a point in time, pick a compiler, pick your flags. You can use that same, like, set of source files and same compiler next week and, like, regenerate your artifacts, whatever, like, that's fine.
I came up with this question because, like, the question about Debian and Ubuntu. So I also have like some background in distributions. And basically, it's not important like to have API compatibility for like a particular like span of lifetime, but just like I agree there must be like particular points where you have to like flag around and rebuild the world. But at least like for example to keep a system stable, just partial updates of particular areas should maybe be possible. And like it's still actually quite difficult to get API compatibility in C++, just like even for small security fixes. And I was just wondering, like, if I know that API Gale is a tool which basically tries to detect like after built binary, so it runs over the shell objects and actually tries to figure out like what happens with help of like debug info, if, what your experiences are, if you don't care at all.
The other security thing that is in the air is SpecHammer. I wait until you see Chandler's talk tomorrow, I guess. Like, I don't know all of the details, but like in the abstract, I can give you 50-50 that all of the compiler fixes by the time we get to the end of this require API changes, right? Like, you're hosed.
But I mean, there are two different things here, right? There are the things where your toolchain or whatever provides you new security features, and then there is a security bug somewhere, and you want to update that. And we know that people actually stay on older versions of software if the update takes longer because there's a higher like risk of it not going through. So that's also a security risk. So I don't think we are in a like clearly in all ways better solution space here. We have trade-offs.
So I mean, binary or API compatibility is fine in the short term. And there are tools and things that we can come up with using a lot of the information that we generate in the compiler to help with that, but it's got to be, you've got to allow the compiler teams, the libs teams, the runtime teams to innovate, to bring in new features, to bring in new functionality, to bring in new security features, to change the way that we do things so you get better performance. And there's all of these things. If you want us to always have that guaranteed abstraction, we're not going to be able to move the state of the art forward.
I'm all in for going fast, but there are just other users I encounter.
Why do you have to partially update inside of a process? Why not update on a process basis? If you static link the world, you just replace the processes that need to be replaced.
You're talking about static linking?
For example, right? That's the point here, is that if you have binary compatibility, then you only have to rebuild one shared object instead of 5.
Yeah, right. But for example, if you are Windows, do you want to ship the whole Windows operating system?
So we do have ways to give you binary compatibility, right? Those do exist. I think the fundamental question you're asking is, why isn't that the default? Why isn't everything binary compatible by default and you have to opt in to not being binary compatible? And it's simply a choice, right? We still have the capability of being binary compatible. If you choose, you can do C, you can do caller allocated memory. That works, right? And that will continue to work for effectively forever.
Right.
So it exists. It has trade-offs. It has significant costs. For most people, it probably doesn't make sense.
For most people, I tend to disagree. I guess that most people actually use daily on their laptops binary API compatibility, so they can work.
Have you supported a library for a decade that has binary compatibility for its users?
I worked with the kernel API, and we basically do that, yes.
And it sucks.
It sucks a lot. But I see the reason, and I guess it's one of the reasons why, for example, Linux is that widely used nowadays, because you can even run 20-year-old binaries on top of the kernel API.
Absolutely. Absolutely.
The other problem you run into with maintaining binary and API compatibility is people start to expect it. It's this observed behavior problem. People see that you haven't changed it for the last 5 years, and it's like, oh, you can't ever change it again. So it's like, so we try to make it easy to upgrade. We try to make it easy to move things forward, but occasionally we have to go and break the world.
We have a little less than 2 minutes. One more question or comment? Not? This is videotaped. It's part of our local user group, the Northwest C++ Users Group. It's nwcpp.org. It'll be on that website. And it'll be hosted by Google's YouTube.
Oh, favoritism comes out.
So thank you, gentlemen, for being on the panel, and thank you, everybody, for coming and asking all these great questions. Thank you.
Oh, wow, really?